Yeah, good day everyone. Yet again is Access Point Academy Physics video lecture. So today we shall be looking at measurement of mass. So mass, but meanwhile there is no how we explain mass without mentioning weight because the two are two different quantities which we need to distinguish. Okay, now mass. Let me start with mass. Mass is the quantity of matter present in an object. The quantity of matter that is actually present in an object, that is mass. So we are made to know that it is a fundamental quantity. It's a fundamental and scalar quantity. So fundamental, it is among the 7 fundamental quantities that we have in physics, and at the same time it is a scalar quantity, which means it has magnitude but no direction to be specified. So now its unit is kilogram, okay, which is kg, and the instrument used for measuring the mass of a substance is called beam balance. So this is quite very important. So if you ask what is the name of the instrument used for measuring mass, so answer is beam balance. So beam balance is the instrument which is used for measuring mass. So examples of beam balance are the butcher's balance, used by the butcher, those that sell meats. Then the chemical balance that is used in chemical laboratory or chemistry laboratory or physics laboratory. Then we have the lever balance. Okay, so they are all examples of beam balances. Okay, so now beam balance we operate based on the principle of moment. Okay, so beam balance we operate based on the principle of moment, which actually states that the clockwise moment is equal to the anticlockwise moment toward the center of gravity. Okay, or the upward forces will be equal to the downward forces toward the center of gravity. So that is the principle of moment. So now beam balance, for it to operate, it will operate based on the principle of moment. Okay, now beam balance, don't forget that it is the instrument we use for measuring mass. Now we were also made to know that the mass of a substance is constant everywhere. When you take a stone that weighs 2 kilograms on the earth, we still weigh or measure 2 kilograms elsewhere, probably in the moon. So when you take the weight of the stone and it measures 2 kilograms, and when you take it to the moon or any of the planet, it's still going to weigh 2 kilograms. So this means that the mass of a substance is constant. Okay, it doesn't change. So now we now look at weight. Okay, now weight is a measure of the force of attraction in an object toward the center of gravity. So measure of force of attraction is quite different from mass, which is the quantity of matter that is present in an object. However, weight is a measure of the force of attraction in an object toward the center of gravity. Now, weight is a vector quantity, unlike mass, which is a scalar quantity. Weight is a vector quantity, and the unit is Newton. Okay, the unit of weight is Newton, the unit of mass is kilogram. So now the instrument used for measuring weight is called the spring balance. So spring balance is the instrument which is used for measuring weight. So it is very, very essential for us to know how spring balance, or on what basis spring balance operates. So spring balance operates based on Hooke's law. Spring balance will operate based on Hooke's law. Okay, so now weight varies from place to place, unlike mass, which is constant everywhere. Weight varies from place to place. So that is the main reason why the acceleration due to gravity, or the gravitational field strength of an object, is not always the same. Okay, the gravitational field intensity, or the acceleration to the gravity, is not always the same because of the fact that weight varies from place to place. The acceleration due to gravity in the earth, for instance, can be taken as 10 meters per second square, or 10 Newton per kilogram, or you take it as 9.8 meter per second square, or you take it as 9.8 Newton per kilogram. Okay, so now weight of an object is not always balanced, is not stable, okay, is not constant, unlike mass, which is always constant. So now don't forget we said spring balance operates based on Hooke's law, which states as the applied force is directly proportional to the extension, provided that elastic limit remains what? Constant. So now that is what Hooke's law says, and spring balance, which is the instrument commonly used for measuring weight, okay, operates based on Hooke's law. So that is it for the measurement of time. Thank you. Bye.